I'm Mark Sponsler, and welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, December 11th.
Stormsurf, waves, weather, buoys, altimetry, snow, temperatures, El Nino, weather analysis, essential data for outdoor people, all the time, no hype.
Be sure and like and subscribe. Ring the bell. You get automatic notifications when the videos are posted, typically on Sunday evenings. All right, let's get to work. Looking at significant wave heights for the North Pacific Ocean, we see seas associated with a gale off of Northern California at about 23 feet, pushing into the coast. A windy, stormy mess is occurring along most of the North and Central California coast, and rain and snow in the mountains. Otherwise, out at sea, a little bit of 18-foot seas near the date line, but nothing really much expected from that. You can actually see seas associated with stronger than usual trades pushing over the Hawaiian Islands. Doing a quick look at current conditions, let's look at the buoys. Half Moon Bay buoy, 46012, Northern California. Looking at all the energy present hitting the buoy, all the way up from 30.3 second period, very long period energy, which there is none, and then the whole way down to 5 second period pure wind chop. And this is the size of the swell in each period band in feet. So at 14.7 seconds, there is swell of 6.7 feet there. At 13.7, 6.2 feet. And really it's all the area under this peak here is what is the primary swell. You see a secondary swell out here and a tertiary swell. And so there's some fancy math you got to do to figure out exactly what each of these component swells are in all this agitated sea state. But the short of it is, primary swell, 11.3 feet at 13.9 seconds from 297 degrees. That roughly comes out to about 15-foot surf. That might be stretching a little bit, but it's definitely big and raw and stormy and a mess along the North California coast. Secondary swell, pure wind swell, 8 feet at 10.7 seconds. That comes out to about 8 feet, something like that. So just a jumbled mess. Next stop is Southern California, Point Loma South Buoy 191. We're using that because it's the most exposed of all the buoys. And again, the same drill, looking at all the energy. You can see a little bump of energy around the 14, 15 second period range, another one around 11 seconds, and a bunch of wind swell all mixed in. Surf from primary swell, primary swell 2.5 feet at 13.4 seconds from 295 degrees. That comes out to about 3.5 foot. And then some wind swell at 4.2 feet at about 6 seconds, or about 2.5 foot. And then finally, the North Shore of Oahu, Waimea Bay Buoy, number 106. You can see not a whole lot going on, mainly wind swell in about the 7 second period range, something like that. Primary swell, 3.5 feet at 7.9 seconds from 42 degrees. That's that northeast wind swell from the trades. It comes out to about 2.7 feet. Hawaiian, we'll say maybe chest high on the face, something like that. So in all, it's a pretty, not a whole lot of surf, and whatever surf there is basically locally generated raw wind swell for North California, a little bit of it bleeding into Southern California, and trade wind swell for the Hawaiian Islands. All right, so let's go take a look up in the upper levels of the atmosphere. Jetstream level, these winds up about 30,000 feet, help support the formation of gales. When they form, help direct their track. We're looking for a trough, a dip in the jet, and well, there is a clear and obvious dip right there. What that helps do, in fact, you can just imagine the winds going this way, falling south, and then doing that, and that sets up an eddy in the atmosphere, a counterclockwise eddy. That's the hallmark of low pressure. Low pressure, of course, if it's strong enough, generates winds. Winds, if they're strong enough, get traction on the ocean surface and generate seas. Seas, as they radiate away from the fetch area, turn into swell, and swell, when it hits your beach, turns into surf. But since the low is likely centered right over Oregon or Cape Mendocino, and the winds are right up along the coast, there is no opportunity for the raw seas to sort of unwrap, and so it's just a jumbled mess of wind swell. Also, so looking off Japan, winds are, what is that, about 150, 160 knots, pushing off Japan. The jet gets to about the date line. It splits. A portion of the energy falls south. Most pushes north, and this is what's been going on for a little bit now. Typical the La Nina syndrome with westerly anomalies. So down here on the equator, they're trying to push into the Kelvin wave generation area. And I know we're going right into the deep end of the pool here, but this is a good way to visualize it. They make it to about 160 east, the split point right about 170 east, so not much beyond that. So the MJO and the westerly wind anomalies that we talk about are really help push the jet a little bit. And the jet looks good till it gets to the date line. Then it splits, and you get, these backdoor troughs pushing down the U.S. West Coast, which is okay because we're getting rain and snow and all that sort of thing from it. But it's between the split, like right here, you just get massive high pressure. That's what's driving the trades over the Hawaiian Islands. And from a macro level, that's what's driving all this. MJO, westerly anomalies, and La Nina splitting the jet. You get this high pressure in between, blah, blah, blah. You get the idea. All right, let's move forward and see what happens. Well, as we get into Monday, the 12th of December, the trough slowly starts pushing inland over California. The jet continues off of Japan. We're looking for any sort of a real trough. And then finally, as we get into Wednesday, the 14th of December, it starts developing again, this on the date line, trying to get traction. But there's also a little bit of a split here going. Actually, the trough doesn't look too bad on late Wednesday into Thursday, north of Hawaii. Maybe that'll generate some seas and get some traction, low pressure somewhere in here. But then look at the split. I mean, it can't be more pronounced there. And the backdoor trough now well into the central United States. The trough continues off of north of Hawaii. Maybe a secondary low will develop here north of the island. Some models have been suggesting that, but that might bring weather into the Hawaiian Islands. And look at this, 190, 200, almost 210 knot winds pushing down. That is great to support some sort of circulation here, and this is on Saturday. And then look at that, it even sort of amps up. It gets a bit pinched as we get into Sunday. That would be a week from now, and then it fully pinches off. But look at this, the jet fully consolidated to about a point almost north of Hawaii. We'll see where all this goes, but it looks reasonably positive. All right, so let's go take a look down at the surface. Surface level pressure, surface level winds, Sunday, December 11th. A little bit of some sort of a low pressure system here. This has been forecast for a couple of days. Trying to get organized on the date line with 40 knot winds, but they're all aimed due to the north. Nothing really at Hawaii. Here's the low pressure system, and you see it's like, what, a 1,008 millibar low? That's not deep. A deep low pressure would be like 960 millibars, something like that. And there's the 30 to 35 knot fetch off the coast and 20 to 25 knot winds pushing into central California, the front almost down into southern California. So we get into Monday, the low pushes down the coast and inland, and that's pretty much the end of it. Now, a secondary low is forecast developing as we get into Monday night and Tuesday off the coast, generating 30 to 35 knot winds. Also some that, and as we get approaching Wednesday, low pressure, as we saw on the jet stream, starts building on the date line. 50 knot winds aim south by Wednesday morning. The secondary low off California all but gone. This low still pretty far to the north, still should generate some seas and swell pushing into mainly the Hawaiian Islands. And it actually sits there just like what we saw on the jet stream into Friday. Let's see, is there, and oh, here we go. This is a little bit different now. Secondary fetch building aimed much better at Hawaii on Saturday into Sunday, 30 to 35 knot winds. The front getting very close to Hawaii a week from now, if not pushing over it, and another system building over the Kuril Islands. So you can see a lot of the action is in this area unless you get troughing down the U.S. West Coast, and then that does things here. But it looks like high pressure starting to build over the mainland, with the focus becoming the dateline region to the northwest Pacific. All right, so what's the effect of those winds on the ocean surface? And you're probably going, where are the wave models? What is this mess? Well, we've had some technical issues. We're having difficulty downloading raw model data from NOAA. I'm working with my technical guy. We're trying to sort it out, but you'll notice the models have been down since Thursday, and they're probably going to be down at least a few more days, but this happens from time to time. Eventually we sort it out and work it. So now, but I'm having to use NOAA's wave model just to give you an idea of what's going on. This is not in feet, it's all in meters. So that's like roughly 20-some feet, 22-foot seas off the North California coast. We'll put this into motion here and just run through it. So we get into Monday, secondary little gale builds again with like 22-foot seas in the northwestern Gulf, falling south and then dissipating. Another system, we saw that building on the dateline as we get into Wednesday with, that's almost 30-foot seas, roughly, and then it starts lifting north, but good fetch aim. Hawaii's right there, so fetch aimed at the Hawaiian Islands. There certainly should be some swell that results from that, and it falls south. And then we know as we get into Saturday, another system is forecast for the dateline. This is, again, it's nothing huge. We're talking, maybe 23-foot seas aimed again at the Hawaiian Islands. And here we are 180 hours out. It starts fading, and another system building off Japan with a rather calm sea state along the U.S. West Coast. Local wind forecast for the U.S. West Coast and Hawaii. High pressure, 1028 millibar. Driving trades at about 20 knots over the Hawaiian Islands out of the east. The local low off Oregon and the Pacific Northwest with 20-plus knot winds pushing into most of the coast and the front pushing into Southern California. We've talked about that already. As we move into Monday, the low pushes down the coast. Northwest winds prevail for California. Trades turning more northeasterly for the Hawaiian Islands at about 15 to 20 knots. As we get into Tuesday, new low off in the Gulf. It's really not off the coast of California. Trades more from the northeast for the Hawaiian Islands, 15 to 20 knots. Winds lighten up for California at 10 to 15 knots and fading as we get through the day. Get into Wednesday, almost a light wind regime for California. Trades back off for the Hawaiian Islands. Low pressure still circulating off the California coast, but getting progressively weaker. Winds turning offshore in California on Thursday at like 10 knots. Trades light for the Hawaiian Islands. So we get into Friday, again, light wind regime for California. Maybe a light south flow. You can see there's weather building north of the Hawaiian Islands, starting to draw air up from the south. As we get into Saturday, maybe a weak little low pressure system off of Point Conception, but generally a light wind regime for California. But looks like light Kona winds northwest for the Hawaiian Islands. And then as we get into Sunday, maybe a little bit of a north wind regime, not much for California, and south winds for the Hawaiian Islands at 10 knots. So nothing too bad wind-wise. California, the worst of it right now. Things getting progressively better as we get deeper into the work week. Now, in regards to precipitation, California getting slammed with rain and snow. I've got about 3 inches in the wind gauge just from I emptied it out on Friday night, or Friday during the day, and Saturday it started, and we've picked up quite a bit of rain already. That translates to feet of snow in the Siera. This was as of 18Z Sunday, and we're really focusing just on precipitation for California here. You see the snow and the rain slowly starting to fade as we get deeper into Sunday. By Sunday night, snow pretty much stops in the Sierra or flurries, but rain continues down the coast, especially into Southern California. But as we get into Monday night, even Southern California starts drying out. The Sierra starts drying out in earnest. By Tuesday, we're back into a light, dry pattern. Same with Wednesday, Thursday, low pressure off the coast, but none of it, maybe little, the models have been like juggling, not quite sure how much of this low is going to spin up and actually push up into the coast. You see there, as we get into Friday, a little bit of rain for central California, maybe almost down to Santa Barbara County. Snow in the central to southern Sierras, but by Saturday, well, this is a better picture now for Southern California. It wasn't like this the previous run of the model. Actually putting rain into Southern California on Saturday and even Sunday. Much needed rain indeed. We'll take it any way we can get it, but most of North and Central California staying reasonably dry. Snow forecast dashboard for Squaw Valley, Palisades, Tahoe. So over Saturday into Sunday morning, they're reporting 3, maybe even almost 4 feet of snow up top and a good amount down at the base, 3 feet of snow at the base, and that's at like 6,200 feet. And then today through the day, perhaps another 8 to 10 inches, something like that forecast, and then nothing after that. It's interesting. The model keeps like moving around. Yesterday's models had 2 other snow events coming in during this week and into next week, and that's all gone. I'm sure the 18Z run of the model will probably give us yet another story. The model's highly unstable, especially more than about 3 or 4 days out. That has been the hallmark of this entire La Nina event. You can't, when you're in kind of a neutral pattern, the GFS model seems to be real well situated, but when you get out on the edges on either La Nina or El Nino, it has a hard time. On La Ninas, it overcalls, it overhypes future weather events. On El Ninos, it does the opposite and undercalls it. So for right now, this is probably as good a guess as any. Snow level still pretty low, and forecast dropping into today down to about almost 1,000 feet. The red is liquid precipitation. The gray is like sleet. The transition from gray to white is the 32-degree line. So down to about 2,000 feet, maybe even 1,000 feet, and then toggling around there for the next couple of days before starting to warm up. But even after the warm-up, still the freeze level right at about the base beyond. Kirkwood in the South Tahoe region doing a little bit better, maybe 14 inches of snow, but with a very similar temperature profile. And then Mammoth in the Central Sierra doing pretty well too, 14 inches, and then another. Now this is that little finger of snow that might pop in from that low midweek, getting maybe 14, 15 inches, something like that. Their base much higher at 8,000 feet, so they're deep into the freeze level, and really just a little blip there on about the 14th and the 15th, and then they're below freezing even at the base for the rest of the time beyond that. All right, let's go take a look long term. What's going on with the Madden Julian Oscillation and the El Nino Southern Oscillation? Those are the 2 major oscillations that affect certainly Pacific, if not entire planet weather over the long term. We're talking weeks to months to almost years out. All right, we're looking for signs of the active phase of the Madden Julian Oscillation. There are 2 phases in the MJO, active and inactive. The active phase is like a low-pressure system, the inactive phase like a high-pressure system. The active phase is on one side of the planet, the inactive phase on the other. They rotate west to east around the planet on the equator. So we're looking for signs of the active phase moving from Asia over on the equator, over the West Pacific, and then making its way across the Pacific. When it does that, it basically stomps on trade winds. Trade winds typically blowing out of the east. The stronger they are, that creates upwelling. We want less upwelling. If anything, we want no upwelling. What that'll do is actually it can reverse trade winds in the West Pacific and take warm water that's typically pushed there by ongoing trade winds, and it pushes it under the equator in what's known as a Kelvin wave, a ball of warm water that traverses the Pacific under the surface, eventually impacting the Galapagos and Ecuador, erupting there. If you get successive active phases of the MJO and successive Kelvin waves, you'll end up with a warm water slick over the Galapagos, and that is how you get the start of El Nino. And of course, El Nino, once it gets going, it sort of digs in, and it does great for surf production, storm production, and precipitation into California. All right, so we're looking at data from the TAO buoy array, a series of buoys strung across the equator used for monitoring El Nino. This is the East Pacific here, West Pacific here. That's the equator. the date line, international date line right there, that's New Guinea. All right, we're just looking at the arrows. These buoys are strung across here, and they have wind sensors on them. These are 5-day average winds. Winds, the longer the arrow, the stronger the wind. So pretty strong out of the east and the East Pacific, pretty strong out of the east and the Central Pacific, and the all-important Kelvin wave generation area. This is where when the active phase moves over this far portion of the West Pacific, not only does it impart energy to the jet stream just through uplifting air, but it also reverses the trade winds here and warmer temperatures. See, these colors are temperatures. Warmer water here, if these arrows change direction, that warm water will start pushing off to the east. All right, but this is the actual wind speeds or the average wind speeds. What we're really interested in is the anomalies, the difference from normal for this time of year. You see trades a little bit stronger out of the east and the East Pacific, just barely a little bit above normal in the Central Pacific, but in the Kelvin wave generation area, still pretty strong out of the east. So this would be indicative of the inactive phase of the MJO, enhanced trades, right? The active phase would be suppressed trades or reverse trades. Let's go look a week out. So 850 millibar zonal wind anomalies from the GFS model. So that 850 millibars is up about 4,700 feet, but that's a pretty good proxy for what's going on down at the surface. You know, it gives us an indication, are trades stronger than normal or weaker than normal? That's all we're looking for. Now, this is the whole planet on one chart. All we care about is the Pacific. The far West Pacific starts at about 135 east, so right about there. Okay. The yellows and the reds are westerly anomalies. Think of that as the active phase of the MJO. The blues, purples, that's the inactive phase of the MJO, enhanced trades. All right, so right now we have a tiny little sliver of westerly anomalies in the far West Pacific, and you see the bulk of the westerly anomalies this is the way it's been this is the typical La Nina signature over the maritime continent, like Bali in that area. Okay, hold up there, a little finger of westerly anomalies, and then on the date line here, oh, that's right, Kelvin wave generation area, so 135 east to about 170 west. So the box right there, that's what we're interested in. So easterly anomalies on the date line. This is the classic La Nina signature when you just have easterly anomalies. Looks like a little bit of a break here on the date line in easterly anomalies. We haven't seen that. Well, we did see a little bit of it here. Maybe a Kelvin wave got generated here in later November, and another little pulse of that. These are actually kind of a good sign. We're starting to see at least a little bit of sense of the MJO trying to wake up. It's just been perpetual easterly anomalies and a very weak MJO signal, or if there is any MJO, it's all biased towards the inactive phase. We want to see the active phase wake up. Let's go look out a little bit further. This is the forecast for outgoing long-wave radiation, fancy words for cloud cover. If the active phase of the MJO is a low-pressure system, then typically it would have clouds associated with it. If the inactive phase of the MJO is high pressure, then typically you would get no clouds, dry, clear air, right? Okay, so this is, the blues are, this is outgoing long-wave radiation, fancy word for cloud cover. If you have negative anomalies, blues, that means you got a lot of clouds. You're not getting sunlight reflecting off the ocean. If you have reds and oranges, then you're getting a lot of sunlight reflectivity. That would be the inactive phase. So the blue suggests the active phase over the maritime continent. And here, oh, and let's get oriented. Sorry, the equator runs right through the middle here. South America, Central America, Hawaii, New Guinea, Australia, Kelvin wave generation area, the date line right there, Kelvin wave generation area right there. So it looks like we have a weak inactive phase fading over the Kelvin wave generation area, active phase trying to push into the West Pacific, but 5 days from now, nothing. It all evaporates and continues at neutral on days 10 and 15 in the model run. Now, this is the statistic model. The dynamic model, the GEFS model, GFS ensemble model, suggests neutral 5 days out, but then the inactive phase just coming from nowhere, taking control. This is not what we want to see. And basically, this would be an easterly anomaly pattern, not good for storm production. Let's go dig a little deeper. Phase diagrams. Again, the statistic model, the dynamic model. The MJO, how do you read this thing? Well, the MJO moves from west to east, from the Indian Ocean. This is just from the Indian Ocean on the equator to the maritime continent, Bali, that area, to the West Pacific, to the East Pacific, under the United States, across the Atlantic, over Africa, back to the Indian Ocean. So you can see past, start here. You can see the past movement of the MJO over, the past 2 months or so. Today, right here, where the heavy dot, that's where the active phase is. If the active phase is outside of this circle, it's strong, okay, or stronger. Out here on the edges of the chart, it's very strong. So right now, active phase, very weak, and forecast per the statistic model, moving to the West Pacific 2 weeks from now, but incredibly weak as to not even be present. Now, the dynamic model here, the GFS model, suggests the active phase racing east and coming the whole way back to the maritime continent 2 weeks from now. Well, wherever the active phase is, so we'll say the maritime continent, the inactive phase is on the opposite quadrant, so over the East Pacific right now, according to both these models. And so basically, neither one of these models is suggesting the active phase where we want it in the West Pacific at any strength at all. Maybe in the next 3 days, it's to barely pass weakly through the West Pacific and gone 2 days later. All this seems a little bit way too fast to be believable. So here's the upper level model going out 40 days, okay? South America, Central America, New Guinea, equator right there, date line right there. The greens are areas favorable for precipitation. That would be the active phase of the MJO. The oranges and yellows, the inactive phase of the MJO. And this being an upper level model, it's up at Jetstream level or even higher, 200 millibars, and it runs about a week ahead of what's really going on down at the surface. So the upper air moves, and then it takes a while for the lower air to sort of get the traction and get pulled across. But anyway, this model suggests wet air over the maritime continent. That'd be the active phase of the MJO, moving its way across the Pacific from, we'll say, the 18th of December the whole way into maybe around the 5th of January, something like that. And then you see the inactive phase making its sweep across the Pacific starting, the first week of January and continuing into later in January. So theoretically, according to this, if there was a sweet spot for storm development, it's now for the next couple of weeks. We're going to look at the CFS forecast going out 1 month. Again, this is the whole plan on one chart. This is past performance here. The blues are easterly anomalies, the inactive phase of the MJO. The oranges and reds, westerly anomalies, the active phase of the MJO. And you can see the pattern. And the date line runs right up the middle. So you can see there's been nonstop easterly anomalies on the date line since September. Typical a La Nina pattern. Little bit of a active phase of the MJO created westerly anomalies, pushing the whole way across the Pacific later in November. We also see sort of a similar one late in October. Here we are today, yet another one trying to make its way across. That's kind of a good thing. Now, the bad news is you can see, so the dotted contour is the inactive phase of the MJO. The solid contour is the active phase of the MJO. Notice how so the active phase is progressing across the Kelvin wave generation area. So date line there. West Pacific is right there, far West Pacific. Kelvin wave generation area right in here. So that's the area we're interested in. Looks like the active phase of the MJO is very weakly, just like spurt, spurt, spurt. Not even a contiguous dark line pushing across the Pacific for the next week to week and a half, something like that. So maybe December 20th, something like that. But then behind that, here's the inactive phase coming across. This current run of the model suggesting strong easterly anomalies right where we don't want them. The model had for weeks been saying we were going to get into a westerly anomaly regime right in this area. Well, now this model's saying, well, maybe not so much, which is a little bit disheartening. That said, we'll have to see how this all plays out. The models are very unstable, and they're bouncing all over the place, even from day to day. So this is not a done deal yet. And then we look at the CFS model going out not a week or 2 weeks, but out 3 months. All right, past performance down here, the forecast up here. Date line runs right up the middle. Kelvin wave generation area starts 135 east. That's the far west Pacific right here. Okay. You can see westerly anomalies, the constant tease of westerly anomalies building in earnest over the Pacific, but not nearly as strong as what they were forecast weeks before. Looks kind of not as impressive as it was even last week. And then even worse, you look here and you see this big ball of easterly anomalies on the dateline and forecast holding out till the end of January. Then after that, the dam breaks. The earlier runs of the models a week ago, months ago, had suggested westerly anomalies fully in control of this area by now. But now all of a sudden the model is hinting at La Nina hanging on a little bit longer than forecast. Let's overlay the MJO. So the dotted contour, inactive phase of the MJO, you see it's pushing across the Kelvin wave generation area from now until, the first week in January, something like that. A little bit stronger than what was forecast, with easterly anomalies in control of most of the Kelvin wave generation area starting about a week from now and going for 1, 2, almost, we'll say almost 4 weeks out to here, right there, something like that, that block of easterly anomalies. And then the active phase of the MJO finally sets up, pushes its way across the Pacific. So typically during La Nina events, you get the active phase of the MJO just disappears and the inactive phase of the MJO just takes over. The active phase is trying to make a comeback. It made a little bit in October. It's forecast to make another push here as we get into January, but there was supposed to be some westerly wind event right here starting about right now. But this latest run of the model just has this easterly anomaly thing getting much stronger than it was previous forecast. I'm kind of hoping that this is a 1 or 2 day blip in the models, and this will soften up and the easterly anomalies won't be as strong and there'll be westerly anomalies in here, but it's a day-by-day thing now. All right, anyway, active phase of the MJO is supposed to push over the Kelvin wave generation area in mid to late January and all through February, even into March, with westerly anomalies holding on after that. Let's overlay the low-pass filter. All right, so this dotted contour is the high-pressure bias locked over the dateline. It's the La Nina signal. Now, what's driving these easterly anomalies is, see this dotted second contour here? It was supposed to die sometime in like late December, early January. Now it's forecast holding on till February. But this is only in the past day or two. This is shown at the models earlier this week had it all cut off somewhere around in here. Okay, with the second contour hanging on longer than forecast as well, and finally not moving to the dateline until the end of model run in March. The low pressure bias, the El Nino signal, is today. Now the good news here is it's not going to retrograde west anymore. It's slowly to move east. And where is that? Well, that is about at least halfway, if not 2/3 of the way through the Kelvin wave generation area by the beginning of March. And that's supposed to drag the westerly anomalies with it. The issue with today's run of the model is this buildup of easterly anomalies on the dateline. We don't know whether it's real or not, or whether it's just the model flopping around like it always does. And maybe tomorrow we'll see westerly anomalies here. We don't know. But for right now, the pattern is not as encouraging as it was a week or 2 or 3 weeks ago. So that's the bad news. The good news is the ocean's actually looking pretty good. We're going to start by looking down in the ocean, deep in the ocean. This is the West Pacific here, East Pacific here. Data from the TAO buoy array, those series of buoys strung across the equator used for monitoring El Nino. We're looking, here are the anchor lines on the buoys. The X's are sensors on those anchor lines. The sensors collect water temperature at depth. Now notice there's a big gap between a lot of these. I mean, it's 600 or 900 miles between each anchor line. But anyway, you take that sensor data, use a model to fill in the gaps, and you get a profile of what's going on down in the ocean. Remember, we talked about Kelvin waves. So this is an attempt to monitor the approach and the production of Kelvin waves. So right now we're just looking at average temperatures. All right. The 29 degree isotherm, see these lines, this is what separates degrees of temperature. The hottest warmer in the West Pacific, the colder water in the East Pacific. The 29-degree isotherm is not there. The 28-degree isotherm, pretty much where it was last week at 175 East. The 26-degree isotherm at about 154. I think it was 153 last week, something like that. So pretty much unchanged. The 24-degree isotherm is at 125 west, and that's somewhere about where it's been. So no real change here. Warm water trying to ease off to the east, but not really making it. But it's not the actual water temperatures that matter. It's the anomalies, the difference from normal. And a clear trend is showing up here. You see warm water 3 degrees above normal. I think last week it was at like 140 or almost 150 west. Now look at it. It's moved the whole way to 130 west. This is a clear sign of an impending Kelvin wave. Warm water down 150 meters, pushing off to the east. With cold water in the East Pacific, 2 degrees below normal, but slowly getting squeezed off, and at some point this is going to act like a bulldozer and just push that cold water up to the surface. It'll stream out off the Galapagos, and then warm water will rush the whole way across the Pacific, eventually, we think, putting the death nail on La Nina. Another model using different technology, painting the exact same picture. Clear, much warmer than normal water, pushing east to, what is that, about almost 125 west. With the last of the cold water here, it's going to get squeezed to the surface, and that'll be the end of it, we hope. And this is the time lapse. You can actually watch the warm water as we got later into October and then November, pushing slowly and steadily off to the east. We talk about watching paint dry. Someone made that, one of our viewers made that comment. It is like watching paint dry. It's a slow-moving train wreck, or in our case, a slow-moving change that is setting up over the Pacific. As we get rid of this cold water, if easterly anomalies fade and do not come back, driven by the active phase of the MJO and westerly anomalies in the West Pacific, then that pretty much should be the end of La Nina and a return to a neutral pattern. Let's keep digging. Sea level anomalies from December 4th. A very positive development here as well. So this is not temperature data, and let's get ourselves oriented here. Chile, Peru, Central America, Mexico, Hawaii up there, the equator there, dateline there, New Guinea right there. These oranges and reds are not temperatures, they are the height of the ocean. So take a satellite, rotates polar orbit around the planet. It measures the height of the sphere of the ocean. Take out the wind waves, the swell, even the tides, and is the sphere of the ocean higher or lower than normal? If you have warm water at depth, it expands, it'll create a bump on the ocean surface. If you have cold water at depth, it contracts and it'll make a divot on the ocean surface. So by reading the height of the ocean, you can tell you can infer whether there's cold water at depth or warm water at depth. What we clearly see is positive anomalies at 5-10 centimeters working their way across the Pacific, right? It's kind of north of the equator, but here we even have a pocket to, where is that? 125 north. That marries up real well with what we're seeing on the other charts, okay? And this cold pocket, which was down to minus 20 centimeters, and then last week was barely 15, that's all gone now completely. We have 10 centimeter negative anomalies, suggesting cold water here is rapidly fading. The Galapagos right there, of course. So the dividing line between the two, somewhere around 125, and we think this Kelvin wave is just going to continue pushing off to the east and signal a transition from La Nina into an ENSO neutral pattern. Upper ocean heat anomaly histogram here. So West Pacific here, East Pacific here, and we have time going back a year. You can see a Kelvin wave pushed across, and right about the same time frame last year, we got an upwelling phase. And then in the spring, early summer, another Kelvin wave pushed across, warm water pushing across. Then we got another massive upwelling event, and you can see, though, temperatures quickly receding off to the east, warm water building in from the west. The question is, will it just be a one and done Kelvin wave cycle, or is this the beginning of a much broader change setting up for the Pacific? What we really want to see is warm water at least taking over more of the Pacific. If the temperatures raise, it's all about evaporation, right? Cold water doesn't evaporate. If it doesn't evaporate, it doesn't transfer energy into the upper atmosphere. And so you end up with cold, stable, high pressure driving, enhancing trades both in the North Pacific and the South Pacific. And then that's what drives these upwelling events. But if you can get enough warm temperature long enough in the West Pacific that it starts pumping energy into the jet stream starts cutting the legs out of the high pressure in the North and the South Pacific, and then the trades start backing off, and then temperatures start rising across the entirety of the equator, then you get back to at least ENSO neutral, if not pushing towards El Nino. So that's what we're hoping for. Here is another chart, upper ocean heat anomalies. This is the upper 300 meters of the ocean surface. Another way to look at it, and this is from 100 west, so that's like south of Mexico, somewhere out to about the date line. But you can see back February, that was a Kelvin wave. This was February this year. July, another Kelvin wave, warm water, and you see now the volume of warm water starting to build, or I should say the volume of cold water starting to decrease, suggesting at a minimum a Kelvin wave. Sea surface temperature anomalies. Now, at the surface, we're not seeing any of this. I mean, there's all this magic going on down deep in the ocean. There's this westerly anomaly thing trying to go on in the West Pacific. But if you just look at the equatorial Pacific, well, this is the anomalies, differences from normal for this time of year. Blues colder than normal, oranges and yellows warmer than normal. You go, well, look at all this warm water out here around the edges. In the end, for whatever reason, it's this little strip from 5 degrees north of the equator to 5 degrees south of the equator, the whole way across the Pacific. That's what matters. And you can see, okay, Chile, Peru, the Galapagos, the equator's right here, Hawaii up there. Colder than normal water, in control of the entire equatorial Pacific. That is, again, what's feeding the trade winds. But we know that there is warm water from right here, the whole way under this whole region right here, pushing off to the east. That's likely starting to push some of this cold water up to the surface. So I wouldn't be surprised to see temperatures falling in this region here for the next month before warm water finally starts gurgling to the surface, at least a month, if not 6 weeks from now. Sea surface temperature trend for the past 7 days. Well, we've had this persistent warming pattern now off of Peru and Chile, and then pockets of it showing up on the equator. During earlier this week, it tended to be a little bit colder, almost bordering on cooler right in here. But again, now we're back to this warming thing. The warming trend week after week after week is what we want to see, because that would suggest that temperatures on the surface are getting warmer. And then finally, the backed off view. You can actually see warming temperatures off of Chile, little pockets along Peru, but nothing wholesale. This whole trend thing down here of the further southern reaches down to 20 and 25 south is steadily getting warmer slowly, suggesting trades are weakening, or at least just the upwelling event, the strength of the upwelling not as strong as it's been in weeks past. That trend continues today. Sea surface temperature trend. So Nino 4, Nino 3.4, Nino 3. What does all that mean? Well, Nino 1.2 is the area just right there on the equator. They just take the equator and they've broken it up into segments. Okay, this is the area right there along the Galapagos and off of Ecuador. Notice, so the blues are cold water, the white's warmer water. Notice the upward trend here. But if we look at Nino 3, that's further out in the central, and the official El Nino monitoring region is the Nino 3.4 region. It goes from 120 west, so from a point south of California out to about the date line. They're all pretty much flat and unchanged, but Nino 1.2, temperatures creeping up a little bit. Here's another index, the Nino 1.2 index. It shows temperatures also creeping up, but again, the neutral line, 0 degrees, is right here. Our current value today, right there, minus 1.229 degrees. Half a degree is the La Nina threshold. So we're still deep in La Nina, trending up slightly, but not of any particular giant magnitude. The Nino 3.4 index, the official El Nino monitoring region, also at minus 1.066 degrees. The threshold for La Nina right here at half a degree. Keep this in mind. 1 degree below normal is about where we are today. One side divergence here. Amplitude of the MJO, the strength of the active phase of the MJO. January 2015, you see big spikes up to, what, four standard deviations above normal. Then we got into 2016, the MJO strength weekend. When you get into El Nino like this, that's what you see is strong active phase of the MJO. When the strength of the MJO weakens, the storm track weakens, the Jetstream weakens, and everything kind of falls apart. We had another little push here in January in 2018, and then things slowly quieted down. In 2020, we did have one push of the active phase of the MJO, but that's pretty much right about when La Nina started. And look, not a single active phase pushing above, what is that, 2 standard deviations above normal. We had a little push last year, and look at us now, even quieter. The longer this goes on, you know the dam's going to break, and we're going to get into that in just a minute. So what does the atmosphere think is going on? Well, we look at the Southern Oscillation Index, difference in pressure between Darwin, Australia, which is in basically the Indian Ocean, and Tahiti, which is in the Pacific Ocean. All right, when pressure is lower in Tahiti, the index goes negative. Hey, we're at minus 0.78 degrees, or 0.78 value. So basically dead neutral. But we've been positive for, well, a pretty good long run. We had a good negative run there in November. That's associated with the active phase of the MJO. But now we've been trending positive. One day is not a trend. I'm not sure that we're actually going negative. Anyway, the 30-day average, you take 30 days of this data, average it out every day. Current value, still positive. We want to be negative here if you're in El Nino, or at least hovering around 0. We're at 9.17 today, so that's sort of still La Nina-ish territory. But we were at 10.73 a month ago, so not so bad, not great, not where we want to be. The 90-day average, this is the El Nino La Nina indicator at plus 13.61. Where were we a month ago? 13.81. So pretty much unchanged. The paint is not drying. And I say that a little bit tongue-in-cheek because, yes, at the surface, it doesn't look like anything's happening, but again, down subsurface in the ocean, things are definitely changing. In the West Pacific, we're seeing signs of change wind-wise and where the low-pressure bias is, and we also see a lot of hype from the models about what's to come. Anyway, 30-day moving SOI graphed out, just give things some perspective. Positive values, this is the La Nina range. Down here in the negatives is the El Nino range. Values since, well, you can see since July 2020, it's been pretty much nothing but upward trend. The downward spikes are the active phase of the MJO. The upward spikes are the inactive phase. When to get into positive territory, you have more upward inactive spikes than downward spikes. Today, at about 10 or 12 or something like that. We've had a good long run here. We want to see this starting to go down, but I think a little bit more upward movement is expected before we start falling. And eventually, we want to see this line somewhere down around, at least somewhere between 5 and minus 5. That would be neutral territory. So finally, sea surface temperature forecast from the CFS model for the official El Nino monitoring region, the Nino 3.4 region, pretty much unchanged from last week. Temperatures, ocean surface temperatures, basically about as cold as they're going to get. Remember I said, remember the 1.0 degree thing? Well, that's what this is suggesting we're at. And that's supposed to go, so this is these are the middle of the month. I was actually at one point thinking it was the beginning of the month, but one of our readers, viewers corrected me and told me it's actually the middle of the month. So November would be about there. December would be about there. That'd be about December 15th. And today is the 11th. So if you really want to get literal, we're 4 days from theoretically the beginning in an upward temperature trend. This is raw data from the CFS model. And from here, by the time we get to mid-January, still, we got to get to the half-degree mark to be in neutral territory. That probably won't happen until the last week of January, first week in February. But then, according to this, it's a steady upward trend from there, pushing into El Nino territory as we get later in the summer. But that's the raw data. This is the more, they call it corrected data, PDF corrected data. It's showing basically the same thing. The transition starting anywhere in probably the next week. Temperatures creeping up to maybe 0.65 or 0.7 degrees as we get into mid-January. And by the end of January, we're in neutral territory. And then barely getting into El Nino territory as we get into August. So for right now, weak westerly anomalies in the West Pacific, easterly anomalies, at least per today's run of the model, forecast to build stronger. But before we get into all that, swell-wise, well, a little bit of activity going on the dateline and forecast. And of course, locally for California, rain and snow. We'll take every drop of it we can get. Doesn't look like a whole lot more is forecast for the next week to 2 weeks out, but then maybe beyond. We're hopeful that something better will happen. Jetstream pretty much splitting on the dateline, but a decent trough forecast over the dateline over the next week with a series of, I wouldn't call them storms, but strong gales on the dateline, likely generating surf targeting primarily Hawaii, but maybe secondary energy pushing into the U.S. West Coast. Still not much of a start to the season, probably the weakest big wave surf season I've ever seen since '95 in the Pacific. And that pattern looks to be continuing for a bit. But longer term, we're looking at the models. Again, we're waiting for the wholesale arrival of westerly anomalies in the West Pacific. That forecast in general now till somewhere mid to late January, something like that. So about a month out. At that time, active phase of the MJO pushing over the West Pacific. And we know we already have one Kelvin wave in flight. Another active phase, if it's strong enough, would give us a second Kelvin wave. The forecast model suggesting sea surface temperatures steadily rising from here, so that would also hint at perhaps a second Kelvin wave, a second active phase of the MJO. But again, that is forecast projections from a model going out a month. If you really want to be purely conservative and say, well, right now everything doesn't look so great, and I don't believe it's going to get better, but the hard reality is La Nina always eventually blows itself out. We're into right now a third year of La Nina. We're thinking that we will be out of La Nina as we get into the late winter, early spring. But the question is, how much of an effect will that have on the storm track? We've been saying we think storm pattern will wake up, the snow pattern will wake up as we get deeper into winter and the early part of spring. We still think that's going to happen, but this little easterly bump in the winds forecast for the next couple of weeks has us maybe a little bit concerned and cautiously backtracking from some of our earlier optimism. So we'll just have to see what's going on. In the meantime, weather models, the wave models on Stormsurf are down. We're trying to work on that. Hopefully we'll get that sorted out. All right, so that's it for this week. If you enjoyed the video, give us a thumbs up. If you have questions or concerns, write them up in the comment section. We'll be happy to reply. We're going to be out doing some things over the next couple of days, so we won't be as on top of it as we typically try to be. But still, I can manage this stuff even remotely. All righty, and so that's it for this week. We'll do it again next week. Same time, same channel. Like and subscribe, ring the bell. You'll get automatic notifications. And we'll see you next week. Thanks for watching.